Hey there, AFDA. Mr. Kimble here. Today we're going through the Unit 8 Lesson 6 notes where we talk about permutations and combinations. Permutations and combinations. Both permutations and combinations are used to calculate the number of different ways that a smaller group can be chosen from a larger group. Okay? We're actually going to have a lot of kind of word problems in this, but it's how many can be chosen, how many different ways a smaller group of objects can be chosen out of a larger group of objects. So I have 20 people in class and I want to pick 2 people to be the class representatives at some school-wide meeting. How many different ways can I pick 2 people out of a class of, 20? Those kind of problems. Okay. It's important that you're able to tell the difference between the two. They are similar, but have one big important difference. With a permutation, the order matters. The order of your 3 objects matters. Okay. And what that means is that if you change the order of the items in your group, it produces a different outcome. Okay, so an example of things that are a permutation. Okay, and honestly, this is how I remember it. Okay, when you go to your locker, you have 3 numbers that you have to dial in order to open that locker. Does the order you put those 3 numbers in matter? It does. If you put the 3 numbers in the wrong order, your locker is not going to open. So the order matters. That is called your locker combination, but it actually should be called a locker permutation. Okay, so a locker combination is actually an example of a permutation because the order that you put those 3 numbers in matters. And that's how I remember that a locker combination should be called a locker permutation. So a permutation is when the order matters. Okay. So some other examples of things that would be a permutation would be if we had class officers. And I can show you why that's a permutation. Say I had a class and I wanted to pick a president, a vice president, and a treasurer. Okay? And I picked student A to be president, student B to be vice president, student C to be treasurer. Okay? Well, what if I have those same 3 people, but I have student B is president, student C is vice president, and student A is treasurer? Is that a different outcome? Even though it's the same 3 people, is that a different outcome? Yes, because the offices they're in are different. So even though it's the same 3 people, the order of those 3 people matters. Changing the order produces a different outcome, which is why picking class officers out of a class of students would be an example of a permutation. For the same reason, if you're naming first, second, third place, that is an example of a permutation. Why? Because if first place was student A and second place was student B and third place was student C, well, if we did it again and student C got first place and student A got second place and student B got third place, it's the same 3 students, but is that a different outcome? Yes. Even though it's the same 3 students, because they got a different place in the contest, that is a different outcome. So the order matters. That is a permutation. Okay, so within a permutation, the order matters. Okay, so then to calculate the number of ways that a smaller group, and we're going to call that smaller group R, can be chosen from a larger group, we're going to call that larger group N in a permutation. We're going to use the following formula. We have NPR. I'm going to rewrite it here so it's a little bigger. NPR. So N is always the bigger number. That's like how many total people or whatever you're choosing out of. R is always the smaller number. It's how many you're putting into the smaller group. And the formula is this. N factorial right, like we talked about last class, divided by n minus r factorial. Notice that on the bottom of that fraction, the n minus r is in parentheses. So that means you're going to subtract first to figure out the number that's the factorial on the bottom. And then, just like we talked about last class, we're going to simplify that expression by trying to cancel out as much as we can to figure out the total number of possible ways a smaller group can be chosen from a larger group in a permutation. So again, a combination is similar, but the big difference is that in a combination, the order does not matter. If you change the order of the things in your smaller group, it is not a different outcome. Okay? So some examples. Well, a permutation was like class officers, like a president, a vice president, a treasurer. A combination would be like a class committee. Okay? So if I have a class committee and it has student A, student B, and student C on the committee, is that different than a committee with student B, student A, and student C? Well, it's the same three students, a different order. Does that matter in a committee? No, these are the same. Okay? So changing the order does not produce a different outcome. That is an example of a combination. Okay? And then instead of like picking first place, second place, third place, if I'm asking for finalists, if I say, okay, we're having a contest and I'm going to pick 3 finalists, and student A is a finalist and student B is a finalist and student C is a finalist, is that different than me saying student C is a finalist, student B is a finalist, student A is a finalist? No, those are the same, because if they're finalists, they're all equal. It's not like somebody is first place, somebody's second place, somebody's third place. They're all just kind of tied. So it doesn't matter the order that I list their names, because they're all the same if they're finalists. So if you're talking about a class committee or finalists, that is a combination. All right, so how do we find the total number of possible ways for a combination? Well, to calculate the number of possible ways, a smaller group can be chosen from a larger group. We're going to call the smaller group R. We're going to call the larger group N. In a combination, we use the following formula. I'm going to write it so it's a little bigger. We say it's NC for combination R. Again, N is always the bigger of the two numbers. It's how many total you have in your larger group. R is always the smaller number. It's how many you're putting into each smaller group. And it equals N factorial divided by R factorial times N minus R factorial. Okay, so again, we did problems like this yesterday where we had 2 factorials on the bottom to try to cancel out the bigger factorial on top. Okay, so that's what we practiced at last class. Today we're going to use it in actual problems. So these are the 2 formulas you need to know. Make sure you have those formulas written down somewhere where you can access it easily, because in these problems, you really have 2 things to do. You first have to figure out, is this an example of a permutation or is this an example of a combination? And then that way you know which formula to use, and then can you simplify the formula correctly? That's what you're doing in these problems. So let's start looking at some examples. Determine if each problem below is an example of a permutation or a combination. Then solve the problem. All right, so number 1, a company wants to choose a 3-person committee to make important decisions. If the company has 30 employees, how many different committees can be formed? Okay. Now, we first need to figure out, is this a permutation or a combination? Well, if we're talking about a committee, right, a committee is a combination. If I say person A and person B and person C are on my committee, is that different than me saying person C and person B and person A is on my committee? No. It's the same committee because they're all equal on that committee. It's not like there's a president who's more important than the others. They're all equal. So me changing the order is not different. It's just me saying the names in a different order. So because the order is not important, this is a combination. Okay. So combination, we're doing NCR, which is n factorial over r factorial times n minus r factorial. All right. Well, in this problem, how many people are in our big group? What's our n? Well, our n in this problem is 30. We're picking out of 30 total people. And that big group of 30 people, we're putting them into a smaller group of what? Well, this is a 3-person committee, so that's my R. So what I'm doing here, instead of NCR, it's really 30C3. So then I just plug in my N. So instead of N factorial on top, it's 30 factorial. On the bottom, instead of R factorial, it's 3 factorial. And then instead of N minus R, it's 30 minus 3 factorial. Well, first thing I would do is subtract. 30 minus 3 is 27. So this is 30 factorial over 3 factorial times 27 factorial. Then just like we talked about last time, we want to cancel stuff out. Okay, 30 factorial is an enormous number. So is 27 factorial. So instead of trying to find those numbers, let's cancel stuff out. We're going to use the 3 factorial and the 27 factorial to cancel out as much of that 30 factorial as possible. Use the bigger one. This 27 factorial on the bottom will cancel out everything on top from 27 all the way down to 1. Remember, 30 factorial means 30 times 29 times 28 times 27 times 26 times 25, all the way down to 1. But that 27 factorial on the bottom will cancel out everything on top from 27 down to 1, leaving me with what on top? Just 30, 29, and 28. Right? The 27 down to 1 got canceled out. But we're not done. We still have that 3 factorial on the bottom. And 3 factorial means 3 times 2 times 1. So let's cancel some more stuff out. Look, are there, for these numbers on the bottom, the 3, the 2, and the 1, are there numbers on top that the 3, the 2, and the 1 go into? Yeah, 3 goes into 30. 3 goes into 30 how many times? 10 times. So that 30 now turns into a 10. Does 2 go into any of the numbers on top? Yeah, 2 goes into 10 and 28. So just do it with one of them. I'm going to do it into the 28. 2 goes into 28 14 times. And then 1 doesn't matter because dividing by 1 doesn't change anything. So what I'm really multiplying is 10 times 29 times 14. And 10 times 29 times 14 comes out to be 4,060. So there are 4,060 different ways that if you have 30 employees, that you could pick 3 people from that group of 30 to make a committee. 4,060 different ways. So again, in this problem, we had to figure out whether it was a permutation or a combination. So we knew which formula to use. Then we plug in our bigger number for N, our smaller number for R, and we simplify. All right, number 2. A teacher has 30 students in her classroom. If the teacher wants to select a president, vice president, and treasurer for the class, how many different ways can the 3 class officers be selected? Well, we said before, if it's class officers, that's a permutation. Why? Because the order matters, right? Our 3 offices, president, vice president, treasurer. If student A is president, student B is vice president, student C is treasurer. Is that different than student C being president, student B being vice president, and student A being treasurer? Even though it's the same 3 people, this is a different outcome. So the order matters. That's why this is a permutation. So our permutation formula, NP for permutation, R, is N factorial over N minus R factorial. But in this problem, what's my N and my R? Well, my N is the bigger number I'm choosing out of. We're choosing out of 30 students. And out of those 30 students, we're picking how many class officers? 3. That's my R. So we're doing 30 for N, P, 3 for R. So we just plug it into that formula. So this is 30 factorial on top. On the bottom, instead of N minus R, it's 30 minus 3 factorial. Well, let's simplify that. 30 minus 3 is just 27. So this is 30 factorial over 27 factorial. Those are both, again, enormous numbers. But if we use them to cancel out, we don't have to deal with those big numbers. We're going to use that 27 factorial on the bottom to cancel out as much on top as we can. So that 27 factorial means 27 times 26 times 25 all the way down to 1. It's going to cancel out everything on top from 27 down to 1. What is it going to leave me with? It's going to leave me with a 30, a 29, and a 28. Because the 27 down to 1 got canceled out. So all I do is multiply those three numbers together. 30 times 29 times 28 comes out to be 24,360 different ways. So if a teacher has 30 students and they want to pick 3 class officers, there are 24,360 different class officer groups that you could have. Okay. Notice, in problem 1 and problem 2, my N and my R were both 30 and 3. But number 1 was a combination, number 2 was a permutation. Look how many more options we had in problem number 2 than in problem number 1. In problem number 1, there were only 4,060 different ways, even though N was 30 and R was 3, because it was a combination. In problem 2, there were over 24,000 different ways, when N is 30 and R is 3, because that is a permutation. So again, it's important that you're able to figure out whether you have a permutation or a combination. All right, let's do a couple more examples together. A race has 40 runners and different prizes are going to be awarded for first, second, third, fourth, and fifth places. How many different ways can the 5 prizes be awarded? Well, if we're talking about first, second, third, fourth, fifth place, that is a permutation. If I have the same 5 runners, but they finish in different places, that is a different outcome. The order matters. That's why this is a permutation. We don't need permutations. Permutation. All right, so my permutation formula is PNPR, which is N factorial over N minus R factorial. Well, what are my N and my R in this problem? Well, the race has 40 runners. That's my N. We're giving out 5 prizes for first, second, third, fourth, and fifth place. That's my R. So I'm doing 40 P for permutation, and then R is 5. So I'm going to replace this N with 40, so it's 40 factorial over N minus R is 40 minus 5 factorial. Go ahead and subtract 40 minus 5, so we get 40 factorial over 35 factorial. Again, those are both enormous numbers, okay? But you don't need to figure out what they equal because you're going to use them to cancel each other out. That 35 factorial on the bottom will cancel out everything on top from 35 all the way down to 1. So what will be left on top? Well, the 40, the 39, the 38, the 37, and the 36. But 35 all the way down to 1 got canceled out. So my answer then is just what I get when I multiply those 5 numbers together. So 40 times 39 times 38 times 37 times 36 comes out to be 78,960,960. So if you have a race that has 40 runners and you're going to give out awards for first through fifth place, there are almost 79 million different ways that those 40 runners could finish in first through fifth place. That's an enormous number. Okay? But again, we figured out this was a permutation because the order mattered. So we used our permutation formula to find the answer. All right, number 4, a singing competition has 20 competitors and the top 5 finalists will advance into the next round. How many different groups of finalists are possible? Well, we mentioned that word finalist before. Okay, whenever you see finalist, finalist means a combination. Okay, because if you're a finalist, it's not like it's first, second, third, fourth, and fifth place. It's saying like, all right, you 5 advance to the next round. Okay, so the 5 people in that group, it's not like one is better than the rest. They're all equal. So me saying the people's names in a different order isn't a different group. It's the same group. So here, because the order doesn't matter, this is a combination. So a combination formula in CR, C for combination, is N factorial over r factorial times n minus r factorial. All right, well, what's my n and my r? Well, we're picking out of 20 competitors. That's my n. And it's the top 5 finalists. That's my r. So this is 20 C 5. So I replace all of my n's with 20. So n factorial on top becomes 20 factorial over. I replace all my r's with 5. So that r factorial becomes 5 factorial. And then instead of n minus r, it's 20 minus 5 factorial. We subtract on the bottom. 20 minus 5 is really 15 factorial. So this is 20 factorial divided by 5 factorial times 15 factorial. Now again, 20 factorial, 15 factorial are really big numbers, but we don't need to figure out what they equal. We're going to use them to cancel each other out. So I'm going to use the 5 factorial and the 15 factorial on the bottom to cancel out as much of that 20 factorial as I can. Okay? Well, the 15 factorial, use the bigger one to cancel out as much as possible. So that 15 factorial is going to cancel out everything on top from 15 all the way down to 1. So on top, what's going to be left of that 20 factorial? Well, it's going to be the 20, the 19, the 18, the 17, and the 16. Because 15 all the way down to 1 got canceled out by that 15 factorial on the bottom. But we're not done with stuff on the bottom. We still have 5 factorial, which is 5 times 4 times 3 times 2 times 1. So what else can we cancel out? Well, 1 I don't have to worry about. 5 goes into 20, so I'm going to cancel out the 5, and 20 divided by 5 is 4. Okay, 4, that 4 could either go into 16, or I could just use that 4 to cancel out the 4 that's now on top of the 20. That's what I'm going to do. This 4 will cancel out that 4. All right, 3. What number does 3 go into? 3 goes into 18. 18 divided by 3 is 6. So now that 18 is a 6, and the 3 on the bottom cancels out. And what does 2 go into? Well, 2 could either go into the 16, or it could go into the 6 on top. I'm going to have it go into the 16. It doesn't matter. 2 goes into 16 8 times. 16 divided by 8 is 2. So everything on the bottom canceled out, and on top we're left with 19 times 6 times 17 times 8. So all I have to do is multiply those numbers together. So 19 times 6 times 17 times 8 comes out to be 15,504. So if you have a singing competition with 20 competitors and you're picking 5 finalists that are going to go on to the next round, there are 15,504 different groups that could go on to the next round. And again, that's what permutations and combinations do. They calculate the number of different ways that a smaller group can be chosen from a larger group. All right, we've done some together. You try some on your own. Okay, we got 2 problems to try on your own. This would be a good point. Pause the video, try these 2 problems, then hit play to make sure you're getting them right. So te toca a ti. Determine if each problem below is an example of a permutation or a combination, then solve the problem. All right, number 5. Says on a language learning app, the 10 users who score the most points for a week in a division are promoted to a higher division within the app. If a league has 50 users, how many groups of users could be promoted to a higher division? Okay. All right, so we're picking a group of 10 users to move on to the next round. Now, in that group, it's not like one gets something different. They all get moved up. So if I say the same 10 people in a different order, is that a different group? No. The same 10 people in a different order would still be the same group that moves on. Okay, this is kind of like finalist. So because it's like finalist, that means this is a combination. Why? Because the order of those 10 users doesn't matter. So my combination formula NC for combination R is n factorial over r factorial times n minus r factorial. So what's my n and my r? Well, my n is my bigger number, that's the 50. The r is the smaller group, that's the 10. So this is really 50 C 10. So in this formula, we're going to replace the n's with 50s and the c's with 10s. So this becomes 50 factorial over r is 10 factorial times n minus r, that's 50 minus 10 factorial. Well, let's subtract 50 minus 10, so we get 50 factorial over 10 factorial times 40 factorial. Then again, 50 factorial and 40 factorial are really big numbers, okay? So instead of trying to figure those out, let's use them to cancel each other out. The 10 and the 40 factorial on the bottom, we're going to use those to cancel out as much of that 50 factorial as possible. Use the bigger one first. That 40 factorial will cancel out everything on top from 40 all the way down to 1. So what's left on top? Well, it's a 50, 49, let me write it up here, 50, 49, 48, 47, 46, 45, 44, 43, 42. Let me move it over. Oh, not you. You stay. I want to move you guys. And 41. But we still have something left on the bottom. We still have that 10 factorial. Well, that's 10 times 9 times 8. 7, 6, 5, 4, 3, 2, and 1. And let's see what else we can cancel out. Okay, well, the 1 doesn't matter. Does 10 go into any of the numbers on top? Yeah, 10 goes into 50. So the 10 cancels out, and 50 divided by 10 is 5. Does 9 go into any of the numbers on top? Yeah, 9 goes into 45. So the 9 cancels out, and 45 divided by 9 is 5. Does 8 go into any of the numbers on top? Yeah, 8 goes into 48. So cancel out the 8, and 48 divided by 8 is 6. Does 7 go into any of the numbers on top? Yeah, it goes into a couple. It goes into 49 and 42. I'd rather get rid of that bigger number, so I'm going to use it into the 49. 49 divided by 7 is 7. Does 6 go into any of the numbers on top? Yeah, and I can do a couple things here. I can either have it go into the 42, or the 6 on the bottom could cancel out the 6 that's on top of the 48. And that's actually what I'm going to do, is cancel out that 6. All right, does 5 go into any of the numbers on top? Well, 5 could cancel out either the 5 on top of the 50 or the 5 on top of the 45. I'm going to use it to cancel out the 1 on top of the 50. All right, does 4 go into any of the numbers on top? Yeah, 4 goes into 44. So the 4 cancels out. 44 divided by 4 is 11. Does 3 go into any of the numbers on top? Yeah, 3 goes into 42. So if you do 42 divided by 3, you get 14. Then does 2 go into any of the numbers on top? Yeah, 2 goes into 46. 46 divided by 2 is 23. So in this problem, what am I left with on top? Because everything on the bottom canceled out. So on top, I have the 7 that's on top of the 49. I have the 47. I have the 23 that's on top of the 46. I have the 5 that's on top of the 45. The 11 that's on top of the 44. The 43. The 14 on top of the 42, and the 41. So my answer is what I get when I multiply all of those together. It's going to be a big number. 7 times 47 times 23 times 5 times 11 times 43 times 14 times 41 equals 10,272,278,170. So there are over 10 billion different groups of 10 users out of that group of 50 that could move up to the next round. That is an enormous number. Okay, but again, I can figure it out by using my factorial notation like we talked about last time to cancel everything out. All right, number 6. A baseball team has 15 players, and the coach must make a batting order for the 9 players who start the game. How many different batting orders could the coach make for his team? Okay, so in baseball, you play 9 players at a time. So somebody bats first, somebody bats second, somebody bats third, all the way up through ninth. So really, you're figuring out first through ninth. Because you're figuring out places, you could have the same 9 people, but they bat in a different order. That is a different batting order. So because the order matters, this is a permutation. So again, the first thing you have to do in these problems, figure out whether you have a permutation or a combination. Here it's a permutation, because even if I have the same 9 people as the 9 players who start the game, if I put them in a different order, that's a different batting order. This is a permutation. So my formula for a permutation NP for permutation R is n factorial over n minus r factorial. Well, what are n and r in this problem? Well, the baseball team has 15 players. That's my n. That's my big group. And the coach is making a batting order for the 9 players. That's my r that start the game. So what we're really doing here is 15p9. So replace all the n's with 15s, replace the r with the 9. So we got n factorial becomes 15 factorial over n minus r is 15 minus 9 factorial. Well, inside your parentheses, subtract. 15 minus 9 becomes 15 factorial over 6 factorial. Now, those are both big numbers, but we're going to use them to cancel out. That 6 factorial on the bottom is going to cancel out everything on top from 6 all the way down to 1. So what are you going to be left with on top? The 15, the 14, the 13, the 12, the 11, the 10, the 9, the 8, and the 7. And it stops there because the 6 all the way down to 1 got canceled out by the 6 all the way down to 1 that was on the bottom of that fraction. There's nothing else on the bottom of my fraction, so my answer is just what I get when I multiply all of those numbers together. So 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 comes out to be another really big number, 1,816,214,400 different ways that you could make a batting order of 9 players if your team has 15 total players. Okay, so again, these numbers get really big really fast. And a permutation and combination is going to help us figure out how many different ways that smaller group can be chosen from that larger group. Well, I'm very excited because today is the last notes video for this school year. Isn't that pretty darn exciting? So no more notes video. This is it. By the time you guys watch this, we're getting really close to the end of the school year, and there's nothing else new for us to learn. So if you have any questions, jot them down so that the next time we meet, we can go over the questions you had. I appreciate you taking the time to watch the video. Have a wonderful day.